Welcome friends to this video tutorial on principle of electrical and electronics engineering subject. In this video we are going to see unit 4. Unit 4 is system and its representation. Now let us see what is the system. System is defined as the number of elements or components which are connected in a sequence to perform a specific function. This is the definition for system. That is, a number of components or elements connected in a sequence to perform a specific function. If you take a fan, now let us take a fan. It consists of housing. Inside this housing you are having a motor, then it is connected to a shaft, and then you are having your wings. You are having a number of components connected in a sequence to perform a job. Now this is called as a system. You take a washing machine. It is having two drums or single drum depending upon the model. Inside this drum you will have a motor, and all these motors are controlled by a panel. Now again, this is also called as a system in which a number of components are connected in a sequence to perform a specific function. Otherwise you can take a bottle filling plant where cleaned bottles are moved in a conveyor belt and filled in a station and then sent to the packing section. This is an example for system. Next, we will see what is a control system. In a system, when output is controlled by varying the input, then that system is called as controlled system or automated system. It is like driving your automated car. You are having two types of car. A car which is having manual gear, and nowadays you are having cars which can automatically shift the gear by itself according to the speed. Now how the gear is shifted by the car? Because of the automation. Here automation is done on the gearing shift. Here there is no automation in the gear shift. This is called as a control system. Or otherwise you can take a washing machine. You are having two type of washing machine, semi-automatic and fully automatic. Here all the process is automated. Here few processes automated. Now this is called as a control system in which output is controlled by varying the input. If you take a washing machine, if you set the RPM or if you set the time, run for 10 minutes, it will run for 10 minutes. After 10 minutes, it will stop by itself. Okay, after 10 minutes, start this process. These are example for control system. Control system is nothing but a system in which output is controlled by varying the input quantity. The output quantity is called as variable or response, whereas the input quantity is called as command, signal or excitation. Here the input quantity is called as command, signal or excitation. Output is called as controlled variable or response. Next we will see open loop and closed loop system. A physical system which does not automatically corrects its variation in its output is defined as open loop system, or you can say that output has no effect on input. You can say that output has no effect on input. or there is no feedback to correct the input. Next, in order to see the block diagram of open loop system, now this is the block diagram of open loop system. You are having input, a system, and output. Here you can see that output does not control the input. In present situation, most of the systems are all open loop system. Only we are having few things which are in closed loop system. The problem with the open loop system is the system output may change due to external disturbance. System The system output may change due to external disturbance, and the changes in the output are corrected manually by changing the input. But if the user is not there, you can see that you cannot make changes in the input. So hence we will not get the desired output. In open loop system, desired output is not achieved. This is an open loop system. Next is a closed loop system. Here output is having an effect on input in order to maintain the desired output. Here output is having an effect on input to maintain a desired output. If there will not be any deviation in the output. If there is any deviation, the system by itself it will change the input and it will maintain the desired output. Next, we will see the block diagram of closed loop system. This is a block diagram of closed loop system. Here you are having reference input, then an error detector, you are having controller block, a open loop system. The main difference between a closed loop and open loop system is in closed loop system you will have a feedback. You will have a feedback. In open loop system you will not have feedback. The output is taken as C of t, that is given as input to your error detector. In error detector you are having two signals. One is your input and output. If there is any change in the output, we will get a different value in the error detector because the changes may be due to external disturbance or malfunction of the system. Now, if there is any change in the output, the system will automatically correct by itself. It will either increase the input is either increased or input is either decreased to maintain the desired output. This operation is taken by controller. Controller will decide whether to either increase the input or decrease the input in order to maintain the desired output. This is your block diagram of closed loop system. Here input is automatically corrected to maintain the desired output. The most important thing in closed loop system is feedback. Next, transfer function. Transfer function is defined as the Laplace transform of output divided by Laplace transform of input at 0 initial condition. This is very important to mark. Transfer function. Transfer function is defined as the ratio of Laplace transform of output by Laplace transform of input at 0 initial condition. This is very important, at 0 initial condition. Next one, advantages of open loop system. Advantages of open loop system are: open loop systems are simple and economical. Systems are not bulky and hence it's simple and low cost because we don't have a closed loop system. Then open loop systems are easier to construct because it is having less component to construct that equipment. Then open loop system are stable. Open loop system are stable. That means the system will not change periodically due to maintenance output. The system will run by itself. Now if you take a tube light, now you take a tube light or fan which is connected to a AC supply. You can notice that whenever voltage is high, the bulb intensity will be high. You can notice that whenever voltage is high, bulb intensity is high. When voltage is low, bulb intensity is low. This is a good example of open loop system. The bulb will do its operation irrespective of the input. If input is good, intensity will be good. If input is low, intensity will be low. The systems are stable when compared to closed loop system. In closed loop system, what will happen? When voltage is low, the bulb, it will try to increase the intensity by doing some changes. Now the output will vary for sometimes. Then if you get the normal output, what it will do? It has to change the intensity and hence the system is not stable. But in case of open loop system, the system are stable. Next, disadvantages of open loop system. Open loop system are inaccurate and unreliable. Open loop system are inaccurate and unreliable because it does not have no feedback. It will operate, it will give you some result, but the result may not be the desired result. And there may be changes in the output due to external disturbance. And these changes cannot be corrected automatically. These changes cannot be corrected automatically. This is another disadvantages of open loop system. Next, next topic is advantages of closed loop system. Closed loop system are accurate. Then closed loop system are accurate even in presence of non-linearities. Then the sensitivity of the system may be made small to make the system to be more stable. The sensitivity of the system can be made small to make the system more stable. Minor variation need not need any automated control. So minor variation at the output may not need automated control and hence The sensitivity of the system can be made small to make the system more stable. Next, closed loop system are less affected by noise. The external noise, it will change the output of the system, but in closed loop system it is not affected because it automatically corrects the output by changing the input by using feedback. Feedback plays a major role in maintaining the desired output of a system. Next, disadvantages of closed loop system. Closed loop system are complex and costly. Feedbacks may lead to oscillatory response. That means the system output will change. Our system output will change constantly because the input changes. This may lead to oscillatory response. Instead of giving you a constant output, the output may vary. If you take this bulb example, which is connected to a input source, you can know that the input voltage will change depending upon external load condition. Because of that, what will happen? The bulb intensity will change. This may lead to oscillatory response. Then the feedback reduces the overall gain of the system. This is another drawback of having a feedback. It reduces the overall gain of the system, and then stability is a major problem, which leads to stability problems. The last two things leads to stability problem because system is having oscillatory response and it reduces the gain of the system. These are the disadvantages of closed loop system. Next, we are going to see some examples of open loop system and closed loop system. The first topic is temperature control system. The first case is open loop system. The first case is open loop system. Here you are having electric furnace which is heated by a heating element. The furnace temperature is sensed by a sensor. It is given to analog to digital converter, then it is given to interface and then it is displayed. Here you can see that is the temperature is maintained by a heating element. This heating element is governed by the relay control. The on and off of the heating element is controlled by relay control, and you can see that here the output is not controlled. That is, you cannot set any desired temperature. You cannot set any desired temperature by you can increase the temperature or decrease the temperature by changing the on off time of the relay. Relay will in turn it will change the on off timing of your heating element. Your temperature can be changed manually. It cannot be changed digitally, or it is not an automated process. Here the need of analog to digital converter is to display the temperature of the furnace. For example, if you are using this furnace for cooking application, temperature is must. You need a certain temperature to maintain the product quality. For a bakeries, for other kind of things, you need to maintain a particular temperature, which is done manually. This is an example of open loop system in which a desired temperature is set. Next one is closed loop system. This is also regarding this temperature. Here we are having electric furnace sensor, analog to digital converter. This is A analog to digital converter, interface circuit, controller. Next, digital to analog converter, amplifier and relay control circuit. Here, first the desired temperature is defined by a keyboard or any input devices. First, the user will define a temperature. Now, according to this temperature, the furnace will either turn on or off. The turning on and turning off is controlled by this relay control circuit. It is controlled by relay control circuit. Now this output temperature is sensed by a sensor. Then it is this. Now this value is an analog value. This analog value is converted into digital value. Then it is given to an interface circuit. Now this digital value is sent to the controller. Here controller will check the actual value with the desired value. Actual value to the desired value. If there is any deviation, it will give an digital signal. If there is any deviation, it will give an digital signal. Now this digital signal is converted into analog by D to A converter. Then it is given to amplifier. The signal is amplified. That is, magnitude of the signal is increased, and then it is given to relay control circuit. If the desired the temperature is low, it will increase the on period. By making these changes, the system by itself it will ensure that the desired temperature is maintained at this output. This is an example of closed loop system. Next example is traffic control system. The first one is open loop system. In traffic control on roadsides, you would have seen two signals. One is automatically controlled traffic signal. One is manually controlled traffic signal. Manually controlled traffic signal are controlled by a person, whereas the automated system are controlled by the system itself. Now let us see how it is happening. In open loop system, a person will check the crowd on 4 sections or 3 sections. By physical verification, he will change the signal. By physical verification, he will change the signal, or it may run in a sequence, or it may run in a time slot, which is defined by the user. These are two ways by which a non-automated traffic signal will operate. The drawback is one side may be crowded, even though you are having crowded area, but this signal may open because of the sequence. Because of the sequence, less crowded area is most commonly operated. This may lead to overcrowding in all the signals. This overcrowding problem can be solved or overcome by going for a closed loop traffic control system. Next one is closed loop system. Here you are having time slot based on traffic density. Before it was based on a slot, but here it is based on a traffic density. That means on 4 roads you will have cameras. This will take constant images of the 4 sections. The road which is having the highest density of traffic, that signal is opened often. Here the overcrowding problem is avoided. Now all these cameras are connected to computer. Computer will decide what signal need to be opened at what time. This is a closed loop system in which overcrowding problem on a single site can be avoided by going for a closed loop traffic system. Next one is numeric control of system. Here the system is used to make tools. Here this system is used to make tools. For that we are having magnetic disk. In this magnetic disk we are having binary datas. We are having binary datas regarding the shape and size of the tools. Regarding the shape and size of the tools, which is given to a reader. This reader will convert this signal into FM pulse. The reader will give an output of frequency modulated signal. It will give a frequency modulated signal. Now this is converted into an analog signal. This is a digital signal which is converted into analog signal by D2A converter. Then this analog signal is amplified, the intensity is increased, then it is given to servo motor. Here servo motor will control the position of the tool head. It will control the position of the tool head. Here all these operations are controlled by magnetic disk, the data from magnetic disk. If you want to start your process, you need to insert this magnetic disk. If you remove the magnetic disk, the system will not function. Now by using this system, what we are trying to do is we are making tools. The problem with this system is you may not get tools of desired size and desired shape because the output is not controlled by input. This is an open loop system. Because of that, we don't have a feedback. If you don't have a feedback, you will not have a desired output. You will not have a desired output. This problem can be eradicated by having a closed loop system. By having a closed loop system. Now this is a closed loop system of numeric control. Here also we are having the same basic blocks, magnetic disk, where it contains the information of your product. It is inserted into reader. Reader will convert the values in magnetic disk into frequency modulated pulse. Then it is given to controller. Controller will check the input signal and feedback signal. It will compare the input and feedback signal from the output. Depending upon the error value, it may either increase the input or it will decrease the input. Next, it is given to digital to analog converter, where the digital signal is converted into analog. Then the analog value is amplified and then it is given to servo motor. At the output of servo motor, the speed of the motor is checked by a tachometer and then it is given to the amplifier. Now the servo motor, it controls the cutter's head position. Because of any external disturbance, if there is a change in the cutter head position, the system will check based on the feedback. Feedback is analog. Now this is converted into digital and then it is given to controller. Now if there is any change within certain period of time, the system will sense it. It will change the input to maintain the output, or it will reduce the input to maintain the output. By this way, we can achieve a uniform product at the output. This will increase the productivity of a plant. Now, closed loop system are nothing but fully automated system. Nowadays, everyone is going for fully automated system. It will reduce your labor cost and it will always increase the production of any process. It will increase the production of any process. Last example regarding the closed loop system is position control system by using servo motor. Here the system consists of a servo motor which is powered by a generator. Now the load's position is controlled by a motor shaft with gear wheel. The load position is controlled by a motor shaft with gear wheel. A potentiometer are used to convert mechanical motion into electrical signal, and then the desired load position is set on from the input potentiometer and the actual load position is fed to the generator field circuit. Actual values given to generator field circuit. The difference between the two will give you an error signal. That error signal is amplified and fed to the generator circuit. The induced EMF or the EMF from the generator, it will drive the motor. By this way you can have a position control over the load. Thank you for watching this video.